I'm Srijon Sarkar. Welcome to the second year lecture of GSHOC. We will be discussing some configurations in geometry. Through problems, I will try to introduce you all to some methods, things, and facts with a heavier emphasis on places of usage and motivation rather than proofs of equation. So we will get started. So you can see a problem. So I have put the screenshot here. So read the problem and try it. Of course, it's quite long and wordy, but try to read the problem and interpret things. And till then, I will allot 2 minutes for this, and after that, I will proceed. Yeah. You can put your ideas in the chat, like DM Summer, you can DM everyone, there's no restriction. You can either DM Devai or Summer or put in everyone in the option
Okay, so I think some of our audience is not familiar with inversion.
Yeah, so I will try to tell. Okay, so who are not familiar with inversion, try to take it as a function. At times, I will say inverting with radius a1 ai, it swaps point pq or so, something like that. I will tell. So take it as a function which swaps to point, interchanges their places, something like that. Or else you can take it as a fact, like this holds, and I take it as a fact. It's not fundamental. Of course, I will give you the proofs after the class. And as I told, I will give a heavier emphasis on motivation, the places of usage, instead of randomly proving 1,000 things. So we will practice through problems, and through them, I will tell you some configurations and things. And yeah, same with projective. Those who are not able to catch what's a harmonic bundle, I will explain a bit. Still, who are not, those who won't be able to catch, take it as a fact. Okay, this holds. Now I will proceed. Later on, when we will learn things slowly, I will be able to get them.
Also, you can use the reflect around circle function in geometry.
Yeah, I'm not sure if everyone is having a GGB open in front of screen and or something like that. So yeah,
Someone would do this in paper.
in paper, most of the inversion is depends on familiarity, how much you have explored and things. In my opinion, so rest. Yeah, you can chat right here. Okay, so did you guys get any response from the audience regarding this question?
It's like a very long question, so it takes some time to complete.
Okay, cool. Okay, so I will give a hint, like I will have to proceed. So read the end part of the question. Of course, it's not an actual question. It's like to make you guys learn something, but still. Yeah, it's a troll, but still. Okay, so anyways, as it's a troll question, so if you read the last line, it's written that proves that g of 100, g sub 100, h, comma h j dashed and h O G G something like that conquers. So if you note that it's given like there are three lines, all of them have a point H, and it asks to tell where they conquer. Of course, if all of them have a common point, they will conquer at that place. So the answer is A. The answer is H, and the problem is of course like a troll, something like that. So the moral was one should always read the questions carefully and in a proper, nice way. And yes, I gave around 10 minutes, I guess, or so, as it was from the beginning. But yeah, the one was one should read the questions carefully. Now we will proceed with actual problems. Okay, let me share screen. Yeah, so this is a warm-up problem. It mostly involves angle chasing, and okay, you guys are able to see, I guess. I have drawn the figures so that you are able to interpret things. And yes, doing over GGB gives away many things like observations which are difficult to find. You get them like in a minute or so. But I had to use a word. You can zoom a bit. You can zoom yourself. Like I guess you can stretch the screen or something. Like zoom, tap, double tap in that area or something like that. Yeah. So I was
In
telling
the
that.
view options, you can edit the resolution for zoom.
No, I am not in laptop. It's in PC. And okay, anyway, I guess you can double tap and. So doing on GGB, like there are many disadvantages and bad things. Like it gives away many things. So that I was telling, but I had to because I don't have a pad or something tablet that I will able to draw by hand. So yeah, I just sorry. Yeah, that's why. That's why to like to save time, I have provided the GGB diagram. Yes. And also because of these reasons, I have avoided including IMO shortlist problems, because like many people take IMO shortlist and those problems quite seriously, and like they don't take hints and solve them instantly. They like to spend time on that, uh, keep trying and things like that. So I have avoided them. But yeah. And because of this, I have taken other countries' Olympiads problem, and I had to take a few. So yeah, this will spoil a few problems for you, but through this, I will make sure that you all learn a bit. No, I'm not saying anything. So no voices are so welcome now.
O isn't labeled.
Okay. Yeah, no, it's there. Also, this problem involves the nice angle measure. So that angle measure you will notice at quite many places, or many of you might have seen. So yes, think of a nice angle measure like say like a minus b by 2, something like that, that you might have noticed, or maybe 2a, like a nice angle measure will be involved here at a place, and rest we will proceed in other way. And most of the problem is built on angle chasing, so nothing much. But yes, it's a nice one. And I won't comment about the difficulty or things. For that, like it's fun to argue about difficulty, but not now. I believe. And I don't think I messed up the diagram. Yes, A is on BC, and F is on the circumcircle of BC, ABC. Hmm. Also, I don't think F is there anywhere in the diagram. I have like put it there for later usage. Okay, so the first hint is try to calculate the angle OAF, and yeah, this angle you are able to notice. I'm hovering the cursor over there. Try to calculate this angle. OAF or OAD, whatever you say. Done. Okay, then write in the chat or DM someone. Not don't write it, like everyone will be able to see then. DM pictures, or you can DM me, I guess. Okay, yeah. Okay, wait. You guys are able to see the source. Don't go in. Don't go over AOPS and search and then tell me. I removed the sources like from here in the problem statements, but then it came over GGB screen. Yeah, I didn't notice that. Someone raised a hand, I guess. OF. The definitions might have been different, right? Yeah. Let's searching over the net and then telling, like, try on your own. Otherwise, I would have, like, I won't click on the link to avoid, like, there may be fishy link or something. Yes, they do intersect. What Nirav is saying is right. Yeah. You said OE, I guess. Samad, I guess someone is raising a hand continuously. I wasn't able to notice the name. Please have a look.
They can ask the doubt in everyone chat. If the doubt is like valid, I can make them unmute. They can DM me the doubt.
Okay. Sir, I wanted. Okay, don't call me sir at least. And anyway, someone looking in the chat. Someone posted this on Twitter. There may be hackers. Someone is writing something. Yeah. Okay, so this was the first thing we require here. DO equal to V minus C by 2. So how many of you were able to get it? You can say in the chat like Y or something like that. Yes. Only one as of now. Okay, and if someone is able to get and like not telling, you can tell like only 19 are here, so it won't matter. Like if you're able to get it and you're not saying, you can say. Hmm. Okay, so I will tell this part like y dA is equal to BC by 2. So you can notice that, and this is very well known, like OAC, that part is 90 minus B, like this is 2B, and that will be 90 minus B. Also, just now you saw me dropping the altitude from A onto BC with J, where J is the foot. So now this is 90, so this will be 90 minus B as well. So this was 90 minus B, and this is 90 minus B. So these two are equal. Now the angle bisector here is the angle bisector of BAC will be the angle bisector of LAO as well, because like we are subtracting equal parts from the angle. So the angle bisector of BAC will be the angle bisector of LAO as well. Now to compute DAO or FAO, whatever you say, because they lie on the same line, this I have defined the point F. So you will calculate FAO considering the double of the thing, like twice multiplied by like LJ. Okay, let me write this text. So AE, and A is isogonal to A is not isogonal to AO. Your AJ is, yes, right. Okay, no. AH and AO are isogonals. They make isogonal pair AH and AO, where H is the orthocenter, not AJ or AE. AJ is the foot of the altitude from A on BC. So DAO is okay. J is the perpendicular. Yes, mean the same. Yes, at that time, like not J, the orthocenter, that or the H and AO constitute a pair of isogonal lines. Yes. Sorry, my screen hanged. 1 second. I have a question. Has anyone drawn the entire okay. Yeah, if anyone has, you can tell him. No. Okay, sorry. Try. I will. So what I told you, try to prove that, then I will proceed further. Sorry. It's a big okay. No, okay, I am giving 2 more minutes. Anyway, my screen is still hanged, so you take the time and try to draw something. Yeah, draw in rough, try to observe and prove that thing. Please show questions. My screen is visible, I guess, just to hang. Okay, now. Okay, now it's now good. Right. Okay, I will have to proceed, I guess. OED. O. Yeah, okay, cool. So after you get this, okay, so as I told, like the angle bisector of BAC is the angle bisector of this line DAO as well. DA is the sorry, let me draw it. Angle bisector of BAC. This is like AD or AF lie on that, and F is the intersection with the circle. That is the angle bisector of JAO as well, as I told, because we are subtracting equal parts like BAJ and OAC are equal. So from that you can calculate angle DAO and you will get this thing, B minus C by 2. And after that, try to prove that AOED, you can see that it is the isosceles trapezium. So try to prove that. Yes, like it's a bad thing. It gives away many important facts away while we are using it. Yes. Not able to see the parallelogram. I don't know, maybe he connected some things and then got it. Okay. Also, my diagram is clear. Like I know it's quite light, but now if I try to make everything darker, it will take time. Yeah. Okay. Yes, Nirav is right. I got the DM. Hmm. So you can notice that as O is the circumcenter of ABC, O equal to OF. So DAO, that is this angle where I'm hovering the mouse, that is equal to this OFA. And as both of these are perpendicular to the same line, we get OF parallel to ED. It's clear, right? Yes. So then we get this angle equals this angle. AFO equal to ADE. And so this angle is equal to this angle. DAO equals to ADE. It's clear? Is it clear? Yes, cool. Okay. So only one way is responding. Thanks. And others, you're able to get it? Cool. Nice. And it's given that OE now OA equals OA. Yeah, okay, anyway, this is a small thing, the parallelogram is saying. Yeah, it's like it's like a nice trivial observation. Okay, so these two angle measures you got equal, and it's given in the question, if you notice, O is parallel to AD. Now with that we get this entire thing of ADEO as an isosceles trapezium. Samar, can you please look into the chat? Someone is saying something and is distracting. So let me write down text A B E O is we want to prove that PQ is tangent to the circumcircle of ABC. And everyone, if you like, pretty much everyone knows the alternate angle segment theorem that R.D. Sharma, R.S. Agarwal thing. So keep that in mind and try to angle chess now. But in my diagram, please insert. Yeah, it will happen. No, I am doing over a software and you are doing in overhand copy. So there will be difference, but it's nice that you are doing copy. Yeah. Cool. So till the isosceles trapezium, it's clear, right? And also everyone was able to get that b minus c by 2 fact, right? How AO equals ED. Oh, note that AO is equal to OF, and OFED, they comprise a parallelogram, as OF and ED are perpendicular to, yeah, okay, cool. So up till here is fine. Okay, nice. Now we mark a point which was there but I removed. It's O dashed. Is the center of ADK. Note that in a question is given that EK equals EA, like EA equals EK. This is an isosceles triangle, and I am marking O dashed as the center of ADK. ADK. K, I mean, like K, the point here is involved with point D and not E. This, like, here is the contrast. So, and you're able to notice quite many nice things. Like, note that the line O dashed O goes towards the midpoint of this triangle AOQ, and then the line through the perpendicular bisector of the AD and OE sides, that passes through O dashed as well. Like, it has quite many nice properties. And yeah, try to work with that along with the thing that I told. Try to keep in mind that alternate segment theorem, that thing, and try to angle chase. Also, if anyone still till now hasn't got that any of the things, feel free to DM any of the hosts if you are not free to message in everyone's section. The but which collinearity? O dashed midpoint. Okay, nice, yeah. Also, that's a contrast thing I told, like we are considering the circumcircle of ADK and not the circumcircle of AKE, whereas like AKE is the isosceles triangle is given. There's not contrast, actually it's given in the question, like the circumcircle of ADK meets BC at P and then meets the circumcircle of ABC at Q. So that follows from there. It's not completely contrasting or something like that. But how is this true? Do we have to? Yeah, yes. You have to prove right now. Okay, no midpoint. Yeah. Like the you know that thing, like the midpoint of a chord, and if you drop the perpendicular from the center of circle to the chord, to a chord, then it will meet at the midpoint. That it's like trivial as well. Yes, cool. And that's really nice. And also, like the perpendicular bisector of AD and OE passes through O dash. That's because like AD is the O dash is the circumcenter of triangle ADK. So like the perpendicular from here when it's dropped, it meets AD at the midpoint. So like this is perpendicular, and then these two are parallel. So this is perpendicular as well. And due to symmetry of isosceles triangle, like this follows that the center falls over the perpendicular bisector. Yes. Good. Finally finished the entire diagram. Yes, right. Okay, did you guys were you able to hear the thing I told, like O dash is the angle bisector of AEK? That thing when I told, I was audible. Yes, okay. Okay, so I will proceed. So that fact holds because, like, again, that same thing. You consider the midpoint of AK, then you drop the perpendicular, it will meet at the same point. Now, note that AEK was given to be an isosceles triangle. So when we drop the perpendicular from E onto the side AK, it will meet at the midpoint of AK due to symmetry and reasons of isosceles triangle. So it follows that E and O dash, yeah, so it has to follow that E and O dashed lie on the perpendicular bisector of AK. So that's why O dashed E bisects AEK, angle AEK. It's the fourth thing. Oh, yeah. Again. Yes, also I'm avoiding a lot of steps, like I'm gulping a lot because I don't want to like give away problems. If anyone is stuck at B minus by 2A, work on, we'll get it. It will be bad if I like tell the solution in some, like telling the full solution, writing the proofs, it will be bad in my opinion. A, E, So I guess this was an important step, and there will be another important step, which is considering AK as 2A. 30 to 45 minutes, right? Uh, and also by important, I mean it's not obvious. I mean it's okay to consider AEK. It's not certain, I will say, because like you see, AEK is given to be an isosceles triangle, and you want nice angle measures. So instead of like taking AEK as A and then working all the way with 90 minus A by 2, A by 2, if you take that to A, you will be able to work with 90 minus A in a simpler manner. Yeah. Samar, what do you mean by 30 to 45 minutes? Actually, I had planned to tell a lot, but it seems like it's consuming a lot of time. Asking when will class end? Yeah, like till now we are not yet through only one problem. Now the problem is solved, I guess. You can DM me. Nirav is still trying. I mean, you two, Nirav, Manav, Man, and Vishrut. Sorry if I'm pronouncing it wrong. You three are the most active or something like that. So other two are solving. You can DM me till then. Yeah, we are discussing the solution only. It's enough to prove okay. Okay. Right. Also, the perpendicular things surrounding the perpendicular bisector of the trapezium, like the parallel sides of the trapezium that I told. From there, you are able to know that O dashed equal to O dashed E. Like there's a small isosceles triangle there, and there's a lot of symmetry at places in the figure. So this you're able to note, right? Yes. So yeah. So yes, right. And we took AEK to be 2A. So AE O dashed is alpha. We can argue by symmetry. Yes, right. So you get AE O dashed and O dashed EK, this to be alpha. Like this angle to be alpha. Because I explained why these are collinear and lie on the perpendicular bisector of AK. So and you took that entire angle to be 2 alpha. So this is alpha. This is alpha. Oh, sorry, I was mute the internet. So I was telling that you were able to notice that this will be alpha and this will be alpha, as we consider that AEK to be to alpha, and I said that reasoning why O dash E lies in the perpendicular bisector of AK. So AE O dash is alpha, and similarly O dash EK is alpha. These things are clear, right? Yes. So now, instead of what someone was saying, trying to chase O, E, A, something like that, like this angle someone was saying, you note that this is alpha and this is 90 degrees. So you get O dash ED to be, and the entire thing to be 90 plus alpha. And due to symmetry of isosceles trapezoid, you get O dash A, O dash O A, this to be 90 plus alpha as well. Yes, let me write down for others. Text. AO dash equal 90 plus A. Yeah. And also the reasoning, the same reasoning follows like y O dash O directs towards the midpoint of AQ, the same midpoint and center of circle reasoning. It's clear? Nice, right. So now note that we got this angle. I'm hovering the mouse there, O dash. So yes, exactly. You get that to be 180 minus 2A. Yeah, I guess that. Not guess that, I mean, yeah. So you get AOQ to be 180 minus 12 to A. Nice. And again, that same 9th class, 8th class thing, that like the angle subtended at any point on the circumference is half of the angle subtended at the center. Like if this is 180 minus 12, the ABQ, so many ideas. Yeah, but all these are basic ideas, right? Some angle chasing and then basic ideas. Let's try hunters. Yeah, anyway, so AOQ, you got to be 180 minus 2 alpha. So ABQ happens to be 90 minus A. Clear? Yes. Now tell what was AQP. What was this? Okay. No. AQP. What will be 90 plus A? I'm not telling about some 90 minus A. It will be 90 minus A. We consider this to be 2 alpha. And here it will be like you take 180 minus 12 and divide it by 2, as AEK is an isosceles triangle, right? Not AQP, AKP. AKP. Yeah. So we took this to be 12, 2A, whatever, 2 alpha 2A. And so this will be 90 minus A and this will be 90 minus A. This is an isosceles triangle, right? So now let me write again. We need to. Yes, so we took AEK to. Right. That's the end thing, right? Done, right. And like One second. So you get B A Q P to be 180 minus A, and like if you extend this line, you get that to be A, and for that and from there we are able to conclude using alternate segment theorem. Yeah, you can like end the proof there. It's not necessary to write alternate segments and alternates. Wait. Here's some confusion. It should. Sorry if I'm pronouncing wrong. So note that. Wait. Let me clear his doubt. So where was I? Okay, we got this angle AOQ to be 180 minus 2 alpha, 2A, whatever, and then from there we got ABQ to be 90 minus A. And now when we are talking about that this isosceles triangle, we took AEK to be 2 alpha, 2A, and so this angle AKP or AKE, this angle will be 90 minus A. So we get ABQ equal to AKE, right? And in the question it was given that the circumcircle of AKD like this meets the circumcircle of ABC at Q. Like basically these points are concyclic. So AKE is equal to AKP, and that's equal to AQP. Not on it, right? So you actually get that ABQ, like this angle is equal to 180 minus this angle APQ, AQP, sorry, AQP, this measure. There is nothing like 180 minus ABQ. It's not like I'm considering this thing. Man is saying AQP. The 90. Okay. One second. 90 plus, yes, that 90 plus thing was here. It got over there and there. Then we moved here at this part, like O dash part. You can like turn on the mic and say it somewhere else. 180 minus 90 minus A, which angle? We get
Yeah. So if AEK is 2 alpha,
yeah.
then AKE must be 90 minus alpha, right?
Can you repeat again last line?
AKE must be 90 minus alpha.
Why will be 90 plus alpha? It will be 90 minus alpha, right?
Yeah, 90 minus alpha.
Yeah, so you get basically this measure equal to this measure, right? You have to notice the hovering of my mouse, right? ABQ equal to AKP.
Yeah.
Because we took this to be 2 alpha, so these two have to be this one, and this one have to be 90 minus alpha, 90 minus alpha. Then the whole sum will be 180, right?
Yeah.
Yeah, so ABQ equals to AQE, AQC, all these lie on the same line, so we can say anything, AQP, I'm saying. And now in the question it was given like ADK, the circumcircle, this one meets the circumcircle of ABC at Q, then the line BC at P, on all those things. So basically we have AQP K, this quadrilateral, to be a cyclic one. So from there we get AKP equal to 180 minus AQP.
Yes.
So from there we get, one second. Okay. Yes. From there we get ABQ equal to 180 minus AQP, not 180 minus A. And here, So yeah, we get AQP equal to 180 minus AQP, and that's why we get ABQ equal to 180 minus AQP. Use latex. Okay, cool. 1 second. Latex formula. 90 minus A equals angle ABQ equals AQP, and that is equal to not 100. AQP. See if it's clear now. Should be. I'm putting on the top. ABQ equals to 90 minus A, and from there you get AQP, and due to concyclic reason, that thing, you get it as 180 minus AQP. Now it's clear, right? Yeah, cool. So now you can finish, like you imagine like I'm extending this, so it's 180 minus, like there is this thing, so you get that to be, wow, done. Yeah, so this measure equals like due to linear pairs, right? This will be I'm considering this as, this will be ABQ basically, this equal to this, and that is what alternate angle segment rules says. Like this angle measure, like I'm not labeling any point out there, so you are able to note that ABQ is equal to 180 minus AQP. So this angle measures happen to be equal to this angle measure, and that is what that alternate means angle segment theorem whatever states. It's clear? Yeah, cool. Like literally this problem took yeah, it's okay, but yeah, more than 1 hour, something like that. And now those who are actively like telling, yes, I'm able to get, all of you are clear with the thing, right? Of course I'm not, I haven't wrote all of the steps here because yeah, because I wanted to present as a walkthrough and not as an entire solution. So cool, yeah, someone also read it, yeah. So let's proceed to the next problem. Okay, I want to plug in the butterfly, like introduce the butterfly theorem here. So let me save this. I will share. Yeah, this is awesome. Cool. And I'm again saying, like the B minus, any of the things you're not able to get it. Yeah, I had plans to cover projective and all those things were there. Like I took 15 to 20, kept 15 to 17 problems in the stock, but I wasn't able to make a guess like it could take this long. Wait, sure. Yeah, I will share the handout and also the walkthroughs and the solutions at places. I'm copying the problem statement. One second. And also the B minus, Hmm. Actually, I should have hidden this. I removed the sources from the problem statement, but then I forgot that I named the GF files after their sources only. So yeah. Okay. Now read, take a few minutes. We won't see the solve. Yeah. Anyway, whoever is seeing, like I'm trying to teach and he's seeing the solve and telling solution and then telling like to act pro or something like that. It won't help anyway. So here's the problem statement and the diagram. Take a few minutes and try. Yeah, right. Yes. So I was telling that the angle measure we saw there, d minus c by 2, I didn't told how you get it. I told that you take some angle, that take the double of it and then, yeah, calculate and get it. So one will get it quite easily. And so it's an angle measure. We know this at quite many places, like in this problem as well. You will get that angle measure. In fact, okay, I am giving it away. So the angle which are asked to find is that angle measure only, d minus c by 2. So you can, instead of finding, prove that. And it's a one liner, I will say. And while telling the solution, I will state the butterfly theorem as well. And it will be nice, I guess. So yeah, you try a bit, you all try a bit, and then I will proceed. Yeah, one liner, don't keep that in mind. I mean, I said one liner because it's, yeah, it's a one liner. The problem is just say a lemma. Yeah, it happens. Okay, I want to share quite a few things, so let me proceed. Means share means I want to introduce your more things, so I will proceed. So the butterfly theorem states that I'm explaining through this diagram. Okay, I have done a similar variation, right? Cool. So the butterfly theorem states that like if m is the midpoint of some chord, here it's labeled as t, and given a circle, like here this it's the circumcircle of ABC. So given a midpoint, given a circumcircle through which two chords pass. So here you note that AD passes through T, and then M sub BC and M sub A passes through T as well. Clear? Clear. And the chords are also, note that this like MBC and MA, these are points on the circumcircle. Also A and B are points in the circumcircle. So the fact that all of them lies in circle is quite important. Next, note we mark the intersections like of AMA with the chord BC, and MBC, M sub BC, we have the line, the segment M sub BC's intersection with BC as F. So we have a chord, its midpoint, the circumcircle. These two chords pass through the point midpoint T, and then we mark the intersections of these two points, and then again of these 2 points with the chord, the whose midpoint we are taking into consideration mainly. So yeah, the configuration is clear. Now the fact is, like this T was the midpoint of BC, and T will be a midpoint of KF as well. This is the butterfly theorem. And all the other things I told, like these two chords pass through T, and then we mark the intersections of K and F. All these are like the conditions. Yes. It's a nice theorem. I first saw in pre-college mathematics, and after that I found a very simple proof of it using. So can you please state it again this time, maybe writing it down? Sure. Text. Yes, James is quite powerful. When you require, it's very hard to spot sometimes, right? Okay, so this is the statement, I guess. Yeah, okay. So I started spelling then. So you have the midpoint of some chord, then through that there are two other chords, like, and after that you mark the intersections of points, like here A and MA, the segment AMA with the segment BC as K, and likewise for the other one. And then the butterfly theorem states that if T is the, as T was the midpoint of BC, T is the midpoint of KF as well. KF. Now the problem should be trivial to note. Okay, I guess I know Pranav. He is in Monsoon Math as well with me. Yeah, hi. Yeah, but I left after that because, like, the lecture notes of this I prepared in the morning. I had some work after that, so I left that chess tournament. Okay, anyway. So note that this butterfly theorem simplifies this problem. If anyone is able to note it, say. Yeah, try it. It's given that AK is the bisector, AT is the median, and we have the condition AC is greater than AB. So this side is greater than this side. I am hovering the mouse. So then let line AT meet the circumcircle at D. Then F is the reflection of K over T. Okay, I think we should keep. Yeah, right, exactly. Okay, so it's given that AK is the angle bisector, AT is the median, and AT meets the circumcircle at point D. And it's further given, yeah, exactly. And it's further given that F is the reflection of K over T. I have marked this point M sub A and M sub BC because you all know fact 5, the incenter excenter lemma. I had written about it in the prerequisites. So like the angle bisector of BSC would meet the arc minor arc PC at its midpoint. That's the fact 5, right? And MBC is just the reflection of it over the circumcenter. Yeah, so I will tell now that the thing is butterfly happens to be easier in a way like it gives us the concurrency of the lines MAT and DF meet at the circumcircle. This is due to butterfly. Note it, like we are given that T is the midpoint of KF and also T is the midpoint of BC. It's given in the question. Like you can say it's a D statement of the butterfly theorem. It's given that T is the midpoint of KF, T is the midpoint of BC as well. Then A, T, D are collinear, and then I have marked these points. Okay, so it was recording to okay, cool. So ATD are collinear, and I have marked this point M A sub BC and M sub A. So now it's the T is the midpoint. It's quite known that all these are collinear, like M sub BC, T. All these are midpoints. So like they lie on the perpendicular bisector of BC. 90 degree, yeah, everything is 90 degree. And then if you want, you can put in the circumcenter and observe. But it's extremely basic, I believe. Here, so you get this to be collinear. This is collinear, and T is the midpoint of this segment as well as this segment. So butterfly forces these lines M sub T and DF to meet at the circumcircle of ABC. Oh yes, this is the catch. Right. Now you will be able to find FDI quite easily. Note that FDI is like this angle. I'm hovering the mouse, and this is equal to this angle. A sub A, M sub A, M BC. This angle. This is the concept. The angle which you are asked to find, what you are asked to find FDA, that's equal to this angle. I'm hovering the mouse due to concyclic reasons. Not a reflection really, but yeah. Yes. Yes. And this you will be able to calculate quite easily because these are fixed points and you know them quite well. This is the midpoint of the minor arc, this is the midpoint of arc containing of arc BC containing A, and then this is the vertex A. Yeah, this is easy. And you will get this again as B minus C by 2, which I will not tell why. You will calculate angle chess on your own. Wow, I proved collinearity but struggling in angle chess. Okay. Okay, I can say, okay, note that this angle is, I'm hovering the mouse, you note that. Okay, no, got it, cool. Okay, cool. Okay. I'll proceed to the next problem. Also, I will like to tell something here, like butterfly has quite less application, like at least for me, I was able to note it in much, what to say, like rear configuration, yes, something like that. I was able to note it in a console problem, something like that. And in 2016 G2 events problem, So these are the two to three places where I was able to note it, and I would have shared more, but the shortlist problem I told I won't discuss or give it away or do anything with it because many take the shortlist seriously. And the console one, I will link it in the PDF when I give it. Yeah, cool. So I will just show a few things and then proceed. Why is the midpoint of KF? One second, one second. Because it's given that F is the reflection of K over T. See the third line in my GGB. Yeah, okay, that's why. It's given in other words, stated in other words. Okay, now that we talked about reflection, like we are talking about reflection, yeah, that was right, they were stated it correctly. That's why I gave that problem in the beginning, told that read problem carefully. Okay, now that we talked about reflection and also the like where we find applications of butterfly, I will link the or put the problem statements of 2016 G2 and the concept problem in the PDF and I will share it. So, okay, now that we talked about reflection, we will try to solve a problem using deflection and symmetry arguments, something like that. I'm sharing the screen. Yeah, I will include that. I have limited time in hand, so I had to exclude those. Yes. This is a problem by Anand Mudgal. Sorry if my pronunciation is wrong. I'm sharing. Okay, this is the problem. Yes. And we are doing, like I removed the problems in between constant and the 2016 G21. Sorry, I shouldn't have told the name or the source. Right. So yeah, I removed the problems that I had kept in between the constant and the 2016 G2 because time is quite limited. So this is the problem. I'm copying the statement once again. Yeah. Text. Latex. This. You all are able to just wait for a minute. He already creates problem and makes his own contests, right? Yes. So, okay, I won't comment about anything because it's recording and we'll go over. Okay, you are able to view my problem statement, right? Or the figure is hiding it. Okay, cool. Hiding a bit of a second. Now it's okay. I will give 5 minutes at least to read and analyze and get a feel of what is happening. Why? Also, I have quite a lot of lines in the diagram. Sorry for that. Search that and okay. Sorry. Probably some conditions. Yes, such that decay. Right. Okay. Yeah, it's understandable. Okay, I won't edit anything. I want to keep the problem statements original because anyway their sources are visible, so I don't want to edit. Okay. And here, like, there will be facts surrounding inversion. So, as I told, those who are not familiar, take it as a fact. Like it holds. Okay, I'm taking it. I'm accepting that it holds. But yes. Yes. It's given that you have to prove OTIs are collinear. I'm not able to see where is C. Okay. Here it is. It's a vertex of triangle of the triangle. Okay. Hmm. I mean, already quite a lot of things are marked in the figure. Like you see the cyclic thing in the circle in the bottom, or like in that area. Then there are collinearities marked in the figure. Rest, yeah. So if like think what would happen if you tried to solve it in hand. At least I'm being honest here. Like I didn't try this problem by drawing using pen and paper or something. No, I'm not using Mac. It's enough, I believe, because like the lectures given by okay, I mean again taking the name of Monsoon Math Camp. Okay, so the lectures there they are given by extremely talented and knowledgeable people like PhDs. Some people are at ISC and like that. Even at their class, okay, I'm seeing. So in even in their class, like we get, they get around 12 to 13 people. So yeah. I mean, there are 6 to 7 instructors, but again, Devayu and someone are trying the problem even huge. So you get it. No, completely free. Okay, anyway, focus on the problem. Yeah, Devayu is trying, I guess. It's quite now. Too hard. Okay, so the first thing I would like to state is that wait, no, okay, 2 more minutes. At 45 I will start telling. I'm like trying to connect the problems in any way possible. Like I started with the China one. Yeah, sure, 3 more minutes. Like I started with the China one where there was the B minus angle measure. We did some things with like basic tools, and from there we proceeded towards the Shargin problem. It involved the angle measure. Then we took a new thing there, like the butterfly theorem. We uh, learned its statement. After that, as there was the reflection things involved, now I am taking an inversion. I'm taking a reflection problem. Like we will solve this problem using reflection and things involved surrounding that. So I'm just connecting or like linking the problems anyhow. Yeah, I in between I removed the problems, 2 problems as I said, but still trying to maintain the link and connection. No, it's not from OTI skull or whatever you're saying. I mean, I know, but you can see the source over the top, in the top. Yes, like after I'm done with a problem, I make their diagrams and then save, post some of our AOPS, and then like I don't post now. Whatever time I used, like whatever problem I used to solve, like a nice ones, I used to make their diagrams and things and then post over AOPS. Yeah, I have, but still I have quite many diagrams and all these GGBs saved. Yeah, you can, but yeah, don't spend too much time in perfecting the diagram, coloring things and all that, because like it may consume your time unnecessarily. Yeah. Okay, 3 minutes passed. I will proceed. I have to make new diagram. Okay, so first note that SI, MBC are collinear. Okay, so Q is the foot of the altitude from, okay, so a few things. So like this is an extremely rich configuration. You will find lot of material surrounding this over the net. Even I linked a few in the prerequisite PDF. So like the foot of something is like that is named like foot of in touch, foot over in touch cord, something like that. You'll find a lot of materials surrounding this. So Q is the foot of the perpendicular from D on FEF, and we extend DQ to meet the circumcircle DEF at R. Then we extend AR to meet the circumcircle of ABC at S. So this is S, point S, how is defined. MBC, of course, you're familiar with, it's the midpoint of arc BC containing A. Similarly, MA is the minor midpoint of the minor arc. This follows from butterfly, right? Is V chord. Not really. No. No midpoint thing is involved here. I guess it's like saying about this where I'm hovering the mouse. AS, VMBC, AT, VST, MBC. That thing. Okay, so yeah, S was defined in that way. I is the incenter and MBC is M sub BC is the thing that I told just now, the midpoint. Now these are collinear. Note that if you like in many places we construct the mixed linear a mixed linear in touch point using the fact like we drop the line and the perpendiculars and do things, then we construct. But now I don't have time to show it anyway. So now we don't have the thing like we are constructing the mixed linear point, so this follows trivially. We are given S to be not to be the mixed linear touch point, we are given it to be the intersection of AR with ABC. Clear the difference? The difference is clear, right? The mixed linear touch point is defined in a different way here. Yeah, okay. So yeah, the first point was this, that yes, it's there. Fourth chapter. It's clear. Now observe more. Okay, also you can notice a point V in the diagram. Is the intersection of AT with ABC. And okay, the fact that AR meets the circumcircle at S and S like S happens to be the mixed linear in touch point, it follows from inversion. Like, and that's why I skipped that part because many of you are not familiar with it. Yes, that follows from inversion, and the rest of the solution is based on one of my friend's work. Yeah, I will link his blog in the handout. I had linked in the prerequisites. I will link again. So yeah, I'm not sure if I will take the real name because, but I can give his AFS Alistair Moody. Yeah, right. So the fact that S, I, MBC and S is the mixed linear things. Once you prove the S is the mixed linear in touch point, you will get the fact that S, I, MBC are collinear. It's trivial. Yeah. So the next point is to note things surrounding the point V. I already have marked the circle here, STVD. So note that why this, like anyone of you are able to observe why this follows the trivial. Okay, nice, then it's trivial, and it follows from the shooting lemma. Yeah, so I was telling that we have got the first fact that SIMBC are collinear. The next thing I told is to observe things surrounding the V, point V. And V is the intersection of AT with the circumcircle ABC. I told to observe things surrounding that. Like I have marked the circle TSVD. Yeah, so observe things surrounding that. Also, like in this way, take a bit of rest, and already it's a complicated diagram, so yeah. Okay, so I told that the fact that the line AR meets the, okay, wait. So AR meets the circumcircle of ABC at S. we have the proof that S is the mixed linear in touch point. That follows from like inversion, and so many of you are not familiar with it. So I told to take it as a fact, like accept its holds. Yeah. So after that we get that SIMBC, M sub BC, that point in the upper part. These 3 points are collinear. After you prove that mixed linear thing, you will be able to get this. So this is a one part done, part one done. The next thing I told is to observe things surrounding point V. So V is the intersection of AT, T is defined in the question, intersection of AT with the circumcircle, that's V. So now you can notice that I have marked a circle T, D, VS there, and also some lines pass through V. So observe things that also, like the diagram is complicated, so like observe while taking a bit of rest, relaxing. So yeah, 2 to 3 minutes I will give there. Actually, yeah, also a lot of things can be drawn from the diagram. It's an extremely rich configuration. Also, I had another AM09 problem, EMMO senior, something like that, but I had to remove due to time constraints. Yeah. Yes, I will give. Not sure if today, because after this, my stomach is already feeling. Okay, so the next thing is we observed that D is the D is the in touch point on BC here, and T is the intersection of AQ with BC. That's there. T done, V done, T and D done. V I told it's the intersection of AT with ABC. Just S is remaining, and S you can see from the question, like AR. Oh, sorry, what I'm saying. S is the mixed linear touch point. So S is the mixed linear touch point. T is the intersection of AQ with BC, and when we further extend AQ, it meets the circumcircle of ABC at V. The fact here is T, S, V, D are concyclic, and this again follows from the shooting lemma, which is like inversion. We invert that in those points with radius M sub BC B squared. Yeah. Shoot. Okay, take your time and like graphs it. Okay, so after inversion, you will get like M sub BC B square. Like, okay, note that you're able to notice my mouse. So this thing M sub BC C M sub BC B, this square will be equal to M sub BC T times M sub BC S, and M sub BC D times M sub BC V. Like the power of points simply. Here, I should have labeled. Yeah, okay, cool. You're able to get it. Nice. That's part 2 here. Right. The point L is also a nice point here. Like it has, okay, I can tell a few nice properties surrounding it. So L is the, it has a name. I would avoid the name, quite like SD lemma. Many of you might know the name, Sharky Devil something. We will avoid that name. L. So we deal with the point L. Okay, so L is a quite a nice point. So heard of it, right? So L is a quite a nice point. I will tell a few properties of it. Like L is the Miquel point of the quadrilateral FBEC, this quadrilateral. Then FLQI, all these are collinear, where Q is the foot of perpendicular from D onto EF, an Einstein center, obviously. Then and these are two properties. Then third property is like LDMA. LDMA, these are collinear. You can see it, I marked just now. Similar to Q point, right? Yes. So Q point is like, I guess it's like Miquel point in orthic picture, orthocentric, something like that. And here it's Miquel point in in-touch picture. Yes. So these are the three properties, right? So these are the three properties. Then the other properties include like this falls in the circumcircle of this AEF. Then yeah, and also I lies on this circumcircle only because it's 90° here and 90° here. And these are the four properties, and rest you can. Okay, I have to tell this four. So yeah, I will keep it till here. Now, okay. Now note that we have defined L to be the intersection of AEFE, AFE, and circumcircle of ABC. Yeah. Nice. Yeah, I gave the plot. Yeah, I gave it. Okay, now as I was trying to link the problem, so we dealt with inversion there and reflection there. Here we will deal with some reflection and arguments surrounding that. So I will zoom a bit so that you are able to notice. Note that S, T, D, V are concyclic due to the shooting lemma, and that follows from inversion with radius of M sub BCB, M sub BCC. Yeah, take it as a fact. Okay, so this is concyclic, and now angle is a bit. So note that PS and SD, these are seems like symmetric, right? Try to prove why. Like ask yourself why. We have the cyclic quadrilateral here, this one. Using that, try to prove why these are like reflection, seems like reflective or symmetric. Yeah. Sorry, I was muted. Not HTV, TSD is right. I'm breaking, that's why I'm breaking into pieces. Like the first part was that inversion thing, that S is the mislinear touch point, and from there only you get like SIMBC is collinear. Done. After in the second part, we shooting lemma again comprises of inversion. So with that you get TDVS, this to be all this to be concyclic. So two parts done. Now it asks to prove that why that SP and SD, these lines seem like symmetric and reflective. Okay, also the inversion, the second inversion, the center of that is, yeah, MBC, this one. With radius M sub BC B or C. That's a midpoint, so it will be equidistant. It's clear, right? All the two parts and thing I told. Almost, okay. Okay, how many of you know Papa's theorem? Kind of. Okay, cool. Okay, so let me first finish that reflection thing. So note that this angle, hexagon, right? Yes, 6 points in cyclic hexagon. Then we take pairs, like, yeah, that thing. I will tell. Let me finish this one. So note that we had this cyclic quadrilateral. So this angle TSD is equal to TVD. Now we zoom out. Note that TVD is equal to AV and AV M sub BC. Like basically this is equal to this, and this thing is equal to this thing, and AV M sub BC is equal to AS M sub BC. Yeah, right. So we get this angle is equal to this angle. Clear? Right. And that's why the reflection thing follows. Like SD is the reflection of SP or vice versa with respect to this line SIM sub BC. Yes. And you can say it like SD is the reflection of AS or AR or SP or whatever. All these are like collinear. So this so with this we're done with the third part. A few more left. Okay, I will proceed. Okay, I want to wrap it by yes, please. Okay. Yeah, IP equal to ID because of radius reasons, like the radius of some circle. Clear? Yes. Now note that we had this reflection thing. SD is the reflection of this line and orange thing. ARP, that line over this ST line. So with this we get that. Also note that TD is tangent to the circumcircle of DF. So due to symmetry reasons, we get TP to be tangent to this circle as well. Okay. Yes, right. Like we had this and this line to be reflection of each other with respect to ST, and we had IP equal to ID to the radius of same circle, that reason. And TD was tangent to is tangent DEF, the circumcircle of DF, and that's why we get TP to be tangent to that circle as well. Right. Cool. Clear. Nice. And now note that IP was equal to ID, so we get that IT is the perpendicular bisector of PD. IT is the perpendicular bisector of PD here. Yeah. Oh yes, right. And now when we combine the fact like this is equal to, I'm hovering the mouse, not telling all the names. This is equal to this is tangent to this, and this tangent to this. These two are equal, and these are deflections. So with all these facts, we get that SP is equal to SD, right? Yes. Yes, right. Now note that we are given that O. What is O? O is not the circumcenter of ABC. It's the circumcenter of MPD. MPD. So let me mark the points. MPD. This small green triangle you are not able to notice, right? Yes. So O lies on the perpendicular bisector of PD. Why? Because like the perpendicular bisector of any like suppose ABC is a triangle, its circumcenter is O dashed. Yeah, so the perpendicular bisector of AB will pass through O dashed, right? Yeah. So this so O lies on the perpendicular bisector of PD, and we just proved that S if SP equal to SD, so S lies on the perpendicular bisector of PD as well. And T lies on the perpendicular bisector, that's clear. Using that fact only we prove that SP equal to SD. And also IP is equal to ID. All I and T are quite nice. We handle them. That S fact we proved SP equal to SD. And as O is the circumcenter of MPD, we got it to lie on the perpendicular bisector of PD. So all this lies on the OTIS lies on the perpendicular bisector of PD, and thus they are collinear. Okay. I'm not sure. I wasn't over AOPS like actively at that time. This is a question from 2019 or ago. Yeah, some people would have. So also we used collineate like this. Of course, is a complex thing. So I explained the solution in as nicely as I could have. We used facts like SIMBC collineate. Also, I'm not sure. Like I missed one thing. I guess I told you guys no Pascal or purpose. Then I missed that part. The concurrency like S. Yes, I missed that part. So ATV and SIMBC they conquered at T. Like you are able to notice my mouse and hovering it. This line and this line they conquer at T. This follows from Pascal. We apply Pascal to that. Okay, I'm writing that, otherwise it will mess up. A V M A S M B C L. This one. A V M A S M sub B C L. Yeah, exactly. And it's not like I'm solving live right now. I have done it before and went over the solution quite many times when I was new to all this. So yeah, anyway, we apply Pascal to this, and then we get that this line and this line meet at T, and this lies on BC. Clear? Yes, cool. So yeah, this like finding that hexagon, the sequence of points to get that these lines intersect over a point on BC, that was the point I missed. And anyway, the deflection thing was clear. So yeah, you're done with the problem. Okay, I have 15 minutes. I will rush through Two problems and we will done. Only two are left. I will be. One problem is extremely trivial. Save it. I'm screen sharing once again. Once again. Share screen. Share. Okay, now you can't see the source because I have labeled it as 2. Yes, I will explain in nice way. Let me copy problem statements. We will utilize few of the problems we just did, like this stems one. That's why. And now I will introduce the Polygon theorem I was talking about. And sorry about pronunciation. The name is Poinset's Polygon. So yeah. Text. Let text. Um, hmm. You're able to see the problem statement, right? Cool. I'm not able to see the chat again. Okay. Okay, the problem statement is quite small in comparison to the ones we did before. So once you're done with the reading, let me know. I will start. Okay, so the Poisson theorem I was talking about, it states that, see, here you have triangle ABC. Why is the chat going away just? Hello. Okay. So okay. So note that fact five. Yes, fact five will be. We will use that somewhere. Okay. So the Poisson statement states that see ABC is a triangle. It has an circle and a circumcircle. Now, if there is some other triangle, suppose here we have M sub A. I'm hovering the mouse. A2 and A1. So if this we draw tangents from M sub A to the incircle and let them meet at the circumcircle of ABC at the points A1 and A2, then the theorem states that A1 and A2 will be tangent to the incircle. Like we have a triangle ABC with circumcircle and incircle. We take another point. Yeah, I'm repeating. So you take another point on the circumcircle and you draw tangents from it to the incircle. Like you draw tangents from M sub A to the incircle and let them meet the circumcircle at A1 and A2. Now the theorem states that A1 and A2 will be tangent to the incircle as well. This is what the theorem states. And this is for the triangle one. The more general version, you can get it. Yeah, you can get it by searching over net. And it uses terms like circumconic, inconic. Yeah, that's the general thing anyway. So, but we require the triangle one. So, right. What he said is right. Now, okay, you all are done reading the problem statement, right? Yes. So I will proceed. Okay, the first claim I make of the problem is note that AI, this line, is the external bisector of this angle A dashed ID. Okay. Okay. So now note that ID is perpendicular to BC, and we know that OMA is perpendicular to BC. Right. Yeah. So you get, I'm hovering the mouse, I'm not telling the angle names, it will be difficult. This angle is equal to this angle due to alternate angles thing we get in parallel lines. Yeah. And this angle will be equal to this angle, radius of same circle, OA equal to OMA. Yeah. And this angle will be equal to this angle. Note that it's given in question I A dashed, like A dash is the foot of altitude from I onto the line A1 and A2. Right, yeah. So this angle is equal to this again due to alternate angles like in parallel lines scenario. Yeah. So we get this. We started with this equal to this, and equal to this. So these two are equal. And you will note that if we draw the bisector of this angle A dashed ID, and we have these two equal, you will get that AI is the external bisector of A dashed ID. Right. You will be able to observe. Okay, so I told that we get these two angles are equal, right? And if we draw the internal bisector of this angle, you can notice like this is equal to this and this is equal to this. So this AI constitutes the external bisector of this angle. Like I have an extended DI. Yeah, so you can see, right? This equal to this. This is the definition of external bisector. Yeah, okay, cool. So this was the claim 1. Now the claim 2 is involves that Poisson thing I told about. So note that we will prove A dashed belongs to the incircle. It's just given that A dashed is the foot from I on A1, A2. We will prove that A dash lies on this incircle. That's trivial, and that follows from the Poisson thing that I told. Like I is the incircle, I is the circle, I is the center of, yeah, I is the center of this in circle D is basically the center of circle DF. So now it's can only make a per 90-degree thing when A1 and A2 are tangent, and the perpendicular, and as per the question, I makes perpendicular with A1 and A2 at A dash only. So you get that A dash lies on the circle. It's clear to everyone, right? Yeah, cool. Then we are almost done. Nice, right, nice. Yeah, we will just deal with the A dash part now. Okay, so we are done with that. Now note that ID is equal to I A dash. Yeah, that's trivial radius of same circle, and we have that external bisector plane. So, and as this is an isosceles triangle, its perpendicular bisector is same as the angle bisector. I'm talking about triangle A dash ID. Yes. 1 second. Yeah. Right. So now this along with the claim is that D A dash is parallel to AI. This line is parallel to AI. So note that we know the fact that internal angle bisector and external angle bisector together makes an angle of 90 degree. And just now I told that A dash ID that is an isosceles triangle. So so when we drop the perpendicular bisector, the angle bisector, and let it meet A dash D at some point, it will make a 90 degree, right? Like say that okay, yes. So 90 plus. Yeah, right. So you get it 90. I'm holding the mouse and not marking points. This will be 90, and this will be 90 as well, right? So now, so they're parallel. A dash D and AI are parallel, right? Right. Okay, and yeah. So we okay. This is done. What else used? Awesome. Yeah. So, 1 second. Okay. When I told about that A dash lies in the incircle, I use the fact 5 certainly. Like someone was telling that we will use the fact 5, right? So I use in a subtle manner. We will able to notice like A like we then consider the triangle AMA, A1 and A2, and we use fact 5 considering A, like A1 equal to AI equal to A2. In that way, we get that like we took the tangents from AMA to the incircle to meet at point A1. I was just thinking about that, it's CPS. So we let them meet a circumcircle at points A1 A dashed and A2 A dashed. But we will prove that those are equal using the fact 5. Yeah, that part I just keep because like, okay, see, this it's not guaranteed that when you make tangents from MA to this incircle, they will go at meet at A1 only, right? So we name the points as A1 dashed and A2 dashed. Now the Polygon theorem states that then A1 dashed and A2 dashed will be tangent to this incircle, and we already have that condition given in the question that A1, yes, and given in the question that A1 equal to AI equal to A2. Combining these two things, we get, and also using the fact that like the radius and tangent makes 90 degree, we get these 2 points to be like same points. The dashed points are equal to the normal points, and also that A like A dash lies on DF. And I will give complete solution if someone is not able to understand. But I guess you people like those are actively telling, yeah. Yes, you're able to get it. Nice. Okay. Okay, so we had that D. Okay, so we have that D A dashed was parallel to AI. Right. This one that I told, this is the perpendicular 90 plus 90, 180, the co-interior, that's why they are paired, the co-interior sum and pair, yeah. So we get that D A dashed is perpendicular to EF. Like AI is perpendicular to EF, and thus D A dashed is perpendicular to EF, right? And others are able to get it right. Like it's clear, and this are parallel, and like AF equal to A tangents from same point, so these two are equal, and that's why AI is perpendicular to EF. And as these are parallel, it makes A dash T to be perpendicular to EF. Yeah. So now remember the stems problem, we had that point R and this same point Q, right? The stems problem, we had this A dash to be point R there, and the Q point was there, right? So now when we extend A dash and let it meet the circumcircle, we get the intersection point, whatever you label it as T or A double dashed, that's the mixed linear interest point. We use the stems problem. I am not describing all the steps again, but as we got this, nice, yeah, the perpendicular, like as these were parallel, we got this to perpendicular to EF, and thus this point is the same as we got in the stems problem, and thus when we extend, join these two and extend to meet the circumcircle, this point constitutes the mixed linear interest point. Yes, even like if you have done the problem before, then it could be not trivial, but still, yeah, helpful. It's clear, right? Right. Thus we are done. So same for other sides, like for B, C, B dash, C dash, you will get the same things. All these mixed linear Sivians. Now you all know the fact, like this is again based on inversion, right? So you get the using the fact that, okay, let me mark it. One second. Okay, you can note that I have marked a point just now, D2, D2. Okay, let it be. Yeah, so those who are familiar with like that thing, diameter in diameter in center configuration, like this constitutes the x point of the x touch point, right? Okay, basically like this is the mixed linear interest point, and this is the x touch point, and these two are like yeah, the last part can be like a bit heavy. So basically this is the x touch point. So the x touch point is like there is a in circle, there exist x circles as well. So x circles are where the point where the x circle meets this line BC, that is the x touch point. From inversion, root BC inversion, we get that take it as a fact, like A T and A D dashed are isogonous. Clear? I will get the same for all the vertices B and C. So now these are known as the Nagel lines. This like A with the AX touch point. Similarly for B and C will get. So all this concur at the, yes. So all this concur at the Nagel point, and the Nagel point lies on what? Nagel, Nagel. This lines, the line joining the point A and D dashed, where D dashed is the X touch point. Yes, you know, in excursion and everywhere it's there. So these Nagel lines will get for the other ones as well, B and C, and all these Nagel points concur at a common point, which is known as the Nagel point. All these Nagel lines compare the Nagel point, right? And this Nagel point lies on OI. That's a fact. You can prove it using bicentric coordinates. It's a fact, like, yeah. And since this isogonal conjugacy holds, like AT and AD dashed are isogonals, so AT, all these mixed linear Sivians, that I told, you can take it as a fact, like, yeah. So all the Nagel lines compare the Nagel point, and that's why all these points like AT dashed, then for BT dash, something you label it, yeah. So all these mixed linear Sivians compare as well, and their intersection, all they concur at a point. The three lines concur, and their intersection lies on OI. Yeah, exactly. Done. So in between, when I told that Poisson thing here, that was PERU-TST, a problem. Okay, so it involves first the claim that AI is the external bisector of A dashed ID. That was there. Then we use the fact that when we put on tangents, like from M to the circle and let them meet at, okay, 1 second. So okay, so note that when I said that fact, like we draw tangents from A to the incircle and let them meet at the circumcircle at A1 and A2. So that fact was like a problem. It was PERU-TST. And okay, sorry, yeah, that was a PERU-TST problem. And after that, we used the stems problem. So this was the actual way I solved the problem. Like it was built on different problems. Right, it's clear, right? And yes, so I had done those problems. That's why I was able to get this problem. So this was, you might have heard about that mock Olympiad by IMO research, like lockdown's most awaited Olympiad. This was the P5 of that that Olympiad. Right. So I won't extend anymore on this. So remaining was like I wanted to share how you, right. Lockdown's most awaited Olympiad. Rest is, it's pretty much it. I guess I covered everything. And yeah, rest I wanted to say that like when making observations, we should look at other triangles. Yeah, I will send it. If not today, I will send surely. So rest I was saying the remaining things were like random ones. So okay, once again. So there is this okay, one second. The problem number is okay, thanks. And I will before that I will end at 45. Okay, so while doing problems, I will link some ones like the one USA TST and IMO shortlist. You get certain observations while looking into other triangles, like an Apollonius circle considering another triangle, like an Apollonius circle with respect to some other triangle, that will give you some important observation while you're dealing with another triangle. This was involving some USTS problem. Yeah. Then while you're doing that Q points things, that will be involved in IMO shortlist problem. That solution, I will link that as well. So there, while you are noting, but I don't know if it's okay. Yeah, you can Google that. I will link it. So in that IMO shortlist problem, you will note that Q points and HM points will be there. So for most of the time, you will be dealing with one triangle. So at a point, you will note that the orthocenter of the main triangle you are dealing with is the orthocenter of another triangle as well. And that will give you another observation as well. So the thing I wanted to say is when you are looking and working with one thing only, Yeah. So when you're looking and working with main one thing only, you can try to look around the bit, change the perspective, and look via another triangle, and it may give you nice observations. And the last point I had put but didn't wasn't able to say due to time constraints was like appreciating Siva's theorem. So there are many theorems like Jacobi's theorem, then Steinberg's theorem, then Blanchett's theorem. So all these theorems are like based on Siva's theorem. And while using Siva's theorem, yeah, I can give the handout. You can share with them. So yeah. So all these theorems can be proved by Siva's theorem and only by ratios, not even anything else. Like say max to max trigonometric expressions will be there, but all these things can be proved by Siva's theorem. Only ratios, nothing else, not like barrier or something. Of course, there may be other methods like all these Jacobi's theorem, Steinberg's theorem, Blanchett's theorem can be proved by Siva's theorem. So yeah, these three theorems can be proved by Siva's, and I wanted to at least the first two, Jacobi's and Steinberg's. Blanchett configuration is quite common, but yeah. So all these big theorems can be proved, and their statements are quite complicated. I won't share now the Steinberg theorem especially. So yeah, that can all these can be proved by Siva's theorem only. And the last was after read or something like that. I wrote something, so that I will share. And yeah, I will conclude the lecture here. I hope you all liked it. Yeah. Also, one second before you all leave, I want to give something. 1 second. This form you are able to open, right? Just check once. Also, like put in honest things because name is optional anyway, and name and email just so that I am able to like get it. I'm taught nicely, or yeah. Anyway, I taught nicely, or my pace was too much. Like I was studying too fast, or was going too fast or too slow. Yeah. So and the form is like completely MCQ like. I have made options because people mostly skip when it comes to writing in words or something like that. 1 second before you put up the recording. So yeah, that's pretty much it. We will link this Google form for my for my feedback in the description box also, and rest I will link the handout in the pinned comment. The team will leave it in the pinned comment. Yeah, we'll finish the session now.